This is for Year 11 methods at 6.7, question number 4 and question number 6. For the first principles, what we are doing is we are limiting the change of x to 0 of f of x plus the change of x minus f of x over the change of x. Now, it doesn't matter if I use h for the change of x, or delta x for the change of x, or lambda x for the change of x. I'm making this my symbol for the change of x. This is y2, that's y1, this is the change of x. So in question 4, the symbolism they use is h, and in question 6, the symbolism they use is lambda x, which is the change in x. Doesn't matter what symbols they use, we do the same process each time. Okay, let's have a look at for E. So f of x equals x cubed, and we're using h. So f of x plus h will equal x plus h cubed, which I know from the expansion of a perfect cube is x cubed plus 3x squared h plus 3xh squared plus h cubed. So to find the gradient function, then f dash of x will equal the limit as h approaches 0 of f of x plus h, which is x cubed plus 3x squared h plus 3xh squared plus h cubed minus f of x, which is x cubed all over h. And that's going to equal the limit as h approaches 0 of this and this add to 0. So I've got 3x squared h plus 3xh squared plus h cubed over h. That's going to equal the limit as h approaches 0 of h outside of 3x squared plus 3xh plus h squared over h. The h's cancel. That's going to equal 3x squared. I can now make h 0. This will equal 0. That will equal 0. So it equals 3x squared. And that's my answer. In question 6, if I was to look at 6e, I'm going to use lambda x, that is the change of x, instead of h, but the process is still the same. So I'd like to do a little bit of work first. I know that x minus 1 x plus 1 times x minus 3 equals x squared minus 1 times x minus 3, which equals x cubed x minus 3x squared minus x plus 3. That's what f of x equals. And f of x plus h will then equal x plus h cubed minus 3 times x plus h squared minus x plus h plus 3, which should equal x cubed plus 3x squared h plus 3xh squared plus h cubed minus 3x squared 2xh, so minus 6xh minus 3h squared minus x minus h plus 3. That's what f of x plus h equals. Okay, so this equals the limit as lambda x goes to 0 of, I used h there by mistake, so that's okay, I can change that. Lambda x, so it's going to be f of x, so x cubed plus 3x squared lambda x plus 3x lambda x squared plus lambda x cubed minus 3x squared minus 6x lambda x minus 3 To avoid the confusion, I'm going to call lambda xh because my handwriting isn't as good and it's going to look a little bit confusing. So this is going to equal the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus 3x squared minus 6xh minus 3h squared minus x minus h plus 3 minus all of this. So that gives me minus x cubed plus 3x squared plus x minus 3 all over h. The 3 and the 3 add to 0. The x and the minus x add to 0. The x cubed and the minus x cubed add to 0, which leaves me with the limit as h approaches 0 of 3x squared h plus 3xh squared plus h cubed. The minus 3x squared and 3x squared disappeared, that went to 0. So minus 6xh minus 3h squared minus h all over h. The limit as h goes to 0 of, taking a common factor of h out, 3x squared plus 3xh plus h squared minus 6x plus 3h minus 1 all over h. The h's cancel to leave the limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 6x plus 3h minus 1. Now I can make h 0, which means I have 3x squared. That becomes 0. That becomes 0. Minus 6x. That becomes 0 minus 1.